Determine whether the following statements are always, sometimes, or never true. We're talking about parallelograms in these questions. So if we look at what a parallelogram looks like, we have some sample parallelograms, but you can also have a parallelogram that is in the shape of a rectangle or a square. So let's look specifically at number 4. The diagonals of a parallelogram are the same length. Well, not necessarily. This distance across is shorter than the distance across this way. But in the parallelogram that is a rectangle, they're the exact same length. So this one is sometimes true. Go through and think about the other 4 questions or statements about parallelograms and determine whether they are always true, sometimes true, or never true. Trace the parallelograms you can compose with 2 identical triangles. In class, your teacher should provide you with some paper triangles. So we have one of them is a 2 by 6 triangle. Let's use the straight edge here. So 2 across and 6 tall. And if we flip the triangles the other direction, we can create a parallelogram that uses the second triangle, which is also a 2 by 6. The other triangle should be a 3 by 4. And again, if we switch those upside down, we can create a parallelogram out of both of those triangles that looks something similar to this. In the previous lesson, we determined that we could find the area of a right triangle by using the formula area equals 1/2 of the base times the height. Why does this formula work for right triangles? Well, 2 identical right triangles can be placed together to form a rectangle. So the area of the right triangles is 1/2 of the rectangle. Do you think that the formula for the area of a triangle works for any triangle, even the ones that aren't right triangles? Let's start by thinking about the area of this parallelogram. Remember, we discussed in lesson 1 the area of a parallelogram can be used by finding the base multiplied by the height. Well, I see the base is 6, but the height should be going at a 90-degree angle from the base. 5 is not the height of this parallelogram. It's the diagonal. The height is measured straight up and down from the base. Now that we have the height, we can find the area of the parallelogram. So we have the base is 6 and the height is 4. So this parallelogram has an area of 24 centimeters squared. What different ways could we cut this parallelogram in half? Here is one way to cut the parallelogram diagonally. If we cut it along this diagonal, do you think we are cutting the parallelogram in half? Explain. Well, this piece here is the same size as the base, and this height is the same height over here in this triangle. So this is cutting the parallelogram in half. meaning that each triangle, the white triangle and the gray triangle, have the same area. Since the parallelogram has an area of 24, each triangle must have an area of 12, because 12 times 2 is 24. This method forms acute triangles. These angles in the corners are all less than 90-degree angles. So that formula of it being half of the base times the height, well, the base is 6, the height is 4, 6 times 4 is 24, split it up into 2 parts, giving us 12, works for acute triangles. What about a different way that we could cut this parallelogram? Here is another way. This time we formed an obtuse triangle. But if we cut it along this diagonal, we are also cutting the parallelogram in half. You can see if we reposition this piece, it's the exact same size as the piece above it. Since the whole parallelogram had an area of 24 centimeters squared, each of these pieces, each of these triangles, is 12 centimeters squared. So we know that this formula works for right triangles, acute triangles, and obtuse triangles. Show 2 ways to decompose the parallelogram to form 2 identical triangles. We can cut it this way, or we can cut it this way. What is the area of each triangle, and how do you know? The base is 6, the height is 4. So that is half times 24, which is 12 centimeters squared. That's the parallelogram's area split in half. Toby uses 2 copies of the triangle to compose a parallelogram. Which parallelogram cannot be composed from Toby's triangles? Let's see, if we take this copy and we try and fit it into the parallelogram, you can see here that this is taking up half of the parallelogram. So another copy of this triangle, like if we rotated it and stuck it down in this corner, 2 of the copies would work here. So A can be composed from this. Here I see this section can be composed of it. And if I rotate and put this piece here, a second copy would fill in the rest of the parallelogram. So B can be composed of those. Here in C, that appears to fill in half of the parallelogram, so we'll need to rotate it to place the other triangle. And it appears C can also be made up of 2 of Toby's triangles. Let's see if we can rotate this piece to fit. This does not appear to fill in Toby's triangle. So that would be parallelogram D cannot be composed from Toby's triangles. For problems 4 through 6, determine the area of each triangle. Remember, just because the base and height may not be on the bottom and going up vertically, the base and height still have to form a right angle. So we have the formula half times the base times the height. So here we have half, the base is 8, and the height is 4. 8 times 4 is 32, and half of 32 is 16. So this one has an area of 16 centimeters squared. For this one, we would say the base is 3, and the height is 2. 3 times 2 is 6, and half of 6 is 3. So this one has an area of 3 centimeters squared. Number 6, the base is 12. The height is 4.5. This 7.5 does not form a right angle with either 4.5 or 12. It is a diagonal measurement, which is not used as either the base or the height. Twelve times 4.5 is 54. And half of 54 is 27. You can think of half as 0.5, or you can divide 54 by 2. Another way that you might see the formula for the area of the triangle is base times height divided by 2. Draw an acute or obtuse triangle with an area of 16 square units. Label the measurements of the base and the height. So remember, when we do the area of a triangle, it is half of the base times the height. So if we want an area of 16, we want the base and height to multiply to make 32. Because half of 32 is 16. So factors of 32 are 8 and 4. So we could have a base of 8 and a height of 4. You could also use 16 times 2 makes 32. So you could have a base of 16 and a height of 2. I'm going to use 8 and 4. And I'm going to draw an acute triangle. 1, 2, 3, 4, 5, 6, 7, 8 for my base. And then I'm going to make my height 4. So if I checked, my base is 8, my height is 4, 8 times 4 is 32, and half of 32 is 16 units squared. In some triangles, we saw that the height was labeled as one of the sides. In other triangles, we saw that the height was labeled on the inside of the triangle. Here, we have a base of 6. The height is not 5 because that's not creating a right angle with the base. We can draw in the height so that it is creating a 90-degree angle with the base. And in this case, the height is outside of the triangle, but it has a height of 4 units. 1, 2, 3, 4. Like you see here. So the area of this triangle, we would have the base is 6 and the height is 4. And for a triangle, the formula is half base times height. Here you can see the parallelogram that would be formed from two of these triangles. So it has a base of 6 and a height of 4, which would give it an area of 6 times 4, which is 24. But for this, it's a triangle, so it'd be half of that, which is 12. Think about where the height might be sketched in for these triangles according to where the base is located. Would you draw the height inside the triangle or outside of the triangle? Let's take a look. Here you can see the height creates a right angle with the base. This one, since it's an obtuse triangle, the height is labeled on the outside here. This one is also an obtuse triangle, so they've sketched out a line from the base to create a 90-degree angle and form the height here. And in this obtuse triangle, they've extended a line through the base so they can create a 90-degree angle and put the height here. Identify 3 possible combinations of bases and heights for the triangles. Label 1 possible combination on each copy of the triangle. Well, in the first case, the base might be here. The base could be here. Or, actually I'm going to do these in different colors so that way we have each triangle labeled in a different color. Or the base could be here. If the base is here, we would need to extend so we can draw in the height outside of the triangle. If this is the base, we're going to create a right angle from there, creating the height here. And in this case, we could extend here to create that right angle and label this piece the height. Determine the area of the triangle. The base in this case is 12, and the height, remember it's not measured diagonally, the height is always perpendicular or creating a 90-degree angle with the base. So the height is 8. 12 times 8 is 96. And then 96 split in half is 48. This one was measured in inches, but area would be measured in inches squared. Which of the following statements are true? Choose all that apply. Any 2 identical triangles can be composed into a rectangle. That is not true, because we saw earlier that identical triangles in some cases can form parallelograms, but they don't form a rectangle unless your triangle has a 90-degree angle in it. So no on A. Any 2 identical triangles can be composed into a parallelogram. Well, yes, because even a rectangle is a type of parallelogram. So right triangles form parallelograms that are specifically rectangles, and then non-right triangles form a traditional or what we think of when we see a parallelogram. Any parallelogram can be composed into two identical triangles by drawing a diagonal in the parallelogram. Yeah, that's true. The area of any triangle can be determined by using the formula A equals 1/2 base times height. Yes, we saw that. In a rectangle, we get right triangles, and in other parallelograms, we can have acute or obtuse triangles, but it works for all types of triangles. The area of any triangle can be determined by using the formula A equals B times H divided by 2. Well, yeah, multiplying by 1/2 is the same as dividing by 2, because remember, it's just flipping that fraction over, like when we were dividing by fractions. It's just a different way of writing the same formula. The base of a triangle must be perpendicular to the height. Yes. The height of a triangle is always one of the sides. No, sometimes it's inside of the triangle, and other times we had to sketch it outside of the triangle. That's all for lesson 3. Make sure you have all the things you need to written in your workbook.